I don't know what happened. So we're good. We're just gonna have to actually like draw the tables like we have been, which is fine. Okay, so actually, let me get, I don't even have my whiteboard app opened yet. Good morning. Today will be 3.3. So we did the truth tables in 3.2 for the disjunction, the conjunction, and like the negation. Today, we're gonna do the truth tables. This is like the title. I'll write it as soon as I get all this pulled up. It's a 3.3 truth tables for conditional, oh, I get the hiccups, and biconditional statements. Okay, so let me get Zoom to show all of this. Share, close. Okay. Okay, is my laptop charged? Because I have it unplugged right now. It is charged, awesome. Okay, so it's 3.3, which is going to be the truth tables for conditional and biconditional statements. We actually are going to do truth tables to kind of explain these, because obviously we learned that with a conjunction, we use the word and they both have to be true at the exact same time. With a disjunction, we use the word or, and it's either or. So the only time it's not true was whenever they were both false. With the conditional statement, it's going to be our if then. And then with the biconditional statement, it's going to be our if and only if. And then we're also going to learn about a tautology, a self-contradiction, and then a way to actually determine what the truth table, what the truth value is. Instead of always, don't get me wrong, the homework, there's a lot of big tables, but there will be problems on the homework and on the test where it might use 3 different statements, but it's only going to key on like a certain case. So it'll be like, figure out what this truth value is when this is true, this is false, and this is false. So it's not asking for every single one. It's asking for TFF, like that one case. I have like 6 pages. And then as soon as I get done, I have y'all's exams. There is notes on them. And obviously after class, if y'all want to stay and talk to me about them, you can. And then I think that was it. Okay, so let's go and get started. So conditional statement. Our conditional statement. Okay, this is our if. We do dot, then. The actual symbol that we will use is the one-sided arrow, or the arrow that points to the right. We know that this one is read if P, then Q, right? So if we do write it, it would look like this. This one is weird to write and say at the same time, but this is, P, then Q, or if P, then Q. Okay, so the important thing, I'm going to go ahead and do a little table right here because we need to talk about it. The important thing about a conditional statement, if you notice that arrow only points one way, and so it actually, let me turn this off real quick. It actually is going to be the only connective and the only thing when we're working on these truth tables where order matters. And so we can do this like little note right here. Order matters. It's very, very important that you remember order matters. I have the world's craziest way of teaching this to you. I'm not even gonna lie. And then I'll show you like the little shortcut to write down to remember, because we have those for all of them. But this is the way I was taught in graduate school. And it's just the way that makes sense, okay? So we know that if we have 2 statements, we're going to have 4 different cases. The first one's where, I want to do this in black, where they're both true, and then true, false, and then false, true, and then false, false. Remember the ones written in black, like you are given those, okay? What we're gonna do right here is just actually the if P then Q. So y'all just follow along with me, okay? So I'm going to now kind of change, you know how when I kept saying like, yes was true and like no was false when we answered things? So now I'm gonna kind of say like, okay, I'm happy is true and I'm not happy is false, okay? So this is the way I was taught. So just imagine this, if you think about case one, right? We're talking about P. Let's say I played the lottery, okay? And I won. I would be happy, right? I would be, okay? Now let's go to case two. Look at it this way. I played the lottery and I did not win, right? I actually played and I did not win. I would not be happy. And then we have, I did not play the lottery, but I still won. Would you be happy? Yeah. Okay. And I'm not even lying. Like when I would do these, I'd be doing my work and I'd be like, I played the lottery. I didn't win. I played the lottery. Like I actually did that. And then this last one, I did not play the lottery and I did not win, even though, yeah, but it's like, I can't be mad, right? I mean, it's like, I can't be mad. Therefore, it's like, I mean, at least I'm not mad. Therefore, I'm happy. This one right here, there's like a note that we will write. And this is what we're going to say. This is true in every case except when you start with T, and I'll use that connective symbol, and you go to F, that's the only time it equals F. Don't get me wrong, I could read more books and I could do more stuff, but when something is taught to you one way and it just makes sense, you just kind of roll with it. And I've always thought of the lottery example here. And so I'm going to tell you right now, this is the one, the third case, that's going to trip people up. Okay, because they're going to know it's a conditional. They're going to see an F and you're going to see a T and you're going to think, oh, false. No, if you start at F and you go to T, you're fine. It's the only time it's false is when you start with T and you go to F. It's when you play the lottery and you do not win. Okay, then I'm mad. Like I actually gave you my money and I didn't win any money. Okay. Okay, so that's the like the little basic baby truth table for our conditional statement. If P then Q, order matters. Okay, and order matters because I'm trying to point out T to F is false, but F to T is not. Okay, so it's not just because it's they're opposite truth values. Okay, the order matters. This right here is the only time that you are going to get your false as like your outcome or like the answer for the truth value. Okay, so now, sorry, I'm trying to change my calculators for my college algebra class, and that was what that was about. Let's do an example where we actually construct a truth table for, and then I'm going to give you like a little, like a statement that we're going to do, like a compound statement. So example. Okay, so we're going to construct a truth table for not P. Oh, I forgot to tell you, there's another word. Let me write it up here. I do apologize. It's just you're gonna add a little word here. So you know how it says if then, and then we have that one-sided arrow, and then we have the if P then Q. When we do 3.4, we're gonna learn a new word. So it's like, why not go ahead and tell it to you now? We could also use the word implies. Okay. So it'd be like, this is saying like P implies Q. It's almost like a cause and effect type of thing. Okay. So, and I was fixing to say it. That's why I wanted to write it. I wanted to say not P implies not Q. That's what we're going to work on. So it's going to look like this. And if you don't use the word imply, then you would just say if not P, then not Q. Okay. And so fairly simple. You know what? I want to move it. Can I copy this whole entire thing and just move it? Nope, can't do it. This is what we're working on. Not P, then not Q. I just didn't want to write it twice. I'm being lazy. Okay. We know that it goes true, true, false, false, true, false, true, false. And then just to kind of follow the same pattern that we were doing, what you would do is you would just pick out what you want to work on first, like which column. I always look at the negations. Well, more specifically, I look at the parentheses first, and then it's like the negations, and then I would do the actual connective last. So I could work on this right here first. And what that's telling me is to negate P, which is just saying whatever you have here in your P column for your truth values, change them, right? Do the opposite. So now I have F, F, T, T. And then you do just kind of pick the next one. If you wanted to do the Q first, it's really, it doesn't matter, right? And so here, I'm going to negate Q. So if I negate Q, my Q column is right here, right? And it's TF, TF. Negating it, opposite truth values would be FT, FT. Okay, so once I've negated those, now I can actually do the implication, sorry, but you know, the conditional statement that we just learned right here. This is going to be our third column as well as our answer column. Okay, because I'm working on any negations, any parentheses. The last thing you do is going to be your connectives on the inside of parentheses and then your connectives on the outside. And you just kind of have to keep up with which one's your answer column. If I now do this, remembering that order matters, go ahead and right here, T implies F, or if T then F, it's the only time I equal F, right? That's my little hint for my conditional. So I'm going to start on this first case. I think, bless you. Yeah, bless you. Peter brought donuts. So right here, if I do this, if I go F, then T, I'm sorry, F, then F, that is going to result in a what? Yes. Okay, and then I look right here. If F, then T, that results in a, yep. And then I look right here. I kind of like the one that disappears, y'all. Then I look right here. If T, then F. That's the only time that I have false. And then the last one, if true, then true. If I play the lottery and I win, then my resulting outcome is true. I kind of wrote that right there wrong because I was talking. I didn't mean to do that. I'm sorry, y'all. So your answer column is T, T, F, T. Okay? And it's because with our conditional, the only time you get false is if you start on the left with a true and then you go to a false. Okay, so the order does matter with this. That is going to be whenever I work on truth tables, I have little notes here. I'd kind of talk to myself. Like I know this means not P, this means not Q. That's why those highlighted columns, I did the negation, right? It's red, not P, not Q. And then above the conditional, that's actually where I wrote this little note right here. I would tell myself, okay, T to F is going to equal F. All right, so if I do have a long one that I'm working on, you could actually like say what it is in your little hints on the top of your table so that it helps you answer your columns. That's a conditional. Okay, order matters. T to F is the only time you get false. Now let's talk about a biconditional. A biconditional, does anybody remember what that symbolically looked like the connective symbol looked like? Yeah. Double arrow. So order doesn't matter. There is a specific like outcome or like two certain truth values that you need to get to like a true or to get to a false. But just remember that if you have a double arrow, order doesn't matter. Okay, you're actually looking for something completely different, to be honest with you. Okay, so biconditional. Was the door still locked? I don't know why. I even tried to use my key and it didn't work. I had to go up the stairs. Which one was on before this? Conditional. Okay, so a biconditional. This is the one where we would write if and only if. But remember, there's a shortcut. It's just IFF because we're going to be lazy in this class and learn acronyms. Make me happy. Okay, this one symbolically is an arrow that points in two different directions. Okay, and whenever you see the little shortcut, it should make sense because it's like, both sides of these arrows match, right? They both have points. And so that's actually what we're looking for. So we want them to match. We want truth values to match. Okay, and then this one right here. Okay, now I don't want to write that. Oh, I don't want to do that either. They're trying to give me my schedule for, let's do our little table for fall. It is Kemp High School, another high school, Terrell, and Athens. It's a lot. Okay, so if we have our P values and our Q values, do y'all know that would be the first time I ever walk inside of a high school? Do you know how crazy that would be to teach and you've never been there before, like ever in high school, like in your life? Like, yeah, that would be crazy. So crazy. Okay, so here's our little truth table. Same thing we've been setting up all the time.
What is the statement?
So here is what we look for. I moved the colors away. This is what we look for. Okay, so true only when P, comma, Q. So it's just saying both of the statements, whatever they are. It could be R and S, T and U, whatever they are, right? Whenever you have this conditional symbol in between two statements, both of these statements. Okay, so true only when P, Q have same truth value. So it looks like this. T, if and only if T gives you T, as well as F, if and only if F. That also gives you true. Because it said as long as they have the same truth value. And right here, those are both true. Right here, those are both false. Okay, so you could think like double T's or double F's or them both being the same, the arrow points in both directions, anything like that. Okay, so whenever we go to answer this first case, true, if and only if true is true. True, if and only if false, these do not match right there. Because those do not match, I do not get a true, I get a false. Third case, false. Last case, true. No, you're good. I thought I moved it for y'all. I'm always in the way. I was even thinking I could sit anywhere. My laptop's charged. I don't know why I'm up here. Should not be, to be honest with you, but whatever. Okay, so instead of doing like a little bitty baby table on my example, we actually got a pretty gnarly looking table, but we're gonna go ahead and do it, okay? Because I know that this is gonna be something that you will see on the homework. I'll give y'all a second because I haven't had a drink on my drink. Make sure you have that written, and then we'll do a fairly large example.
No, Barry Sherlock is well with famous version.
What? Who? What? What?
Barry Sherlock.
Who is that? What? I have no idea who you're talking about. I don't. Example. I kind of like the last name though, Sherlock. Okay, so here's our example, and y'all don't hate me because it's good practice for your homework. It's going to be a PRQ table. Okay, so I'm actually going to go ahead and just start doing all of the values that we need. And these are given to us, remember? It is going to be 8 values, yep. It's technically because they have a base of 2, they could be true or false. And then because there's 3 of them, you would raise 2 to the 3rd power, which gives you 8. Okay, so here's our actual statement that we're going to be working on. It's going to be not P if and only if open, not Q, then R. I'm going to go ahead and start doing the values for our P, our Q, and our R. P is 4 T's and then 4 F's. Q is 2, 2, 2, 2. R is, it alternates. Okay, like there is a pattern. But remember the P, Q's, and R's, stuff like that, you're given all these values. I've just yet to figure out how to simplify teaching this without having to write all of these. No, it's better than being told just to read a book. Yeah. So what I'm gonna do, I'm actually gonna kind of cover up the word example, and then I do need this. I wish I could move that. I'll zoom out. I hate being zoomed out, but whatever. Excuse me. Okay, so I don't have highlights on here. But I would personally, I would tell myself, like, I know this means not P. I know that here TT as well as FF is going to be what equals true. If that's not shorthand, I don't know what is. I know that this means not Q. I know that here, if I start at T and I go to F, that's the only time I get false. And then my R is kind of annoying because I'm actually just going to be copying that R. So what I've always said is I start in the parentheses, and then once I look at the parentheses, if there's a negation, personally, I just do that first. Y'all, this is just being copied. If you just copy it, copy it. I'm not gonna lie though. I'll just do that. I'm gonna stray from my notes. So I'm gonna do what looks to be the easiest thing inside of the parentheses, which is to just copy this R down. My R alternates TF, 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 TF. Now it's just a matter of me staying somewhat in the lines. I'm just copying. Why am I so thick? I'll get it. Okay. And then once I've copied my R, so this was like the first column that I did. The second column that I would do now is actually the negation of Q. Q goes TTFF, TTFF. So right here, I'm going to write the negation of Q, which would be FFTT, FFTT. And that'll be the second column that I've worked on. So FFT, T, FFT, T. That was the second thing I worked on. Now I'm actually going to do the implication of, or the if this, then that. I need to finish those parentheses. And so what I'm going to do is this. I'm going to actually do this operation, which goes, it starts here and it looks here. The order matters. The only, true, 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 false. That very, very last one ends up being false because this is the only one. Remember, here's my little hint. Whenever I do this column, I'm looking for starting at T and going to F. Okay, so, yes, sorry. Peter saw it right here as well. Sorry about that. So honestly, let me kind of do the highlights that we have been doing just to break this up. I've been putting the notes on Canvas for everybody. I don't know if I want to circle that too inside of there. And I just want to have some continuity for whoever has been accessing those. Hey, that was one whole column. This is one whole column. Maybe I could go ahead and say here also that what we're doing is we're just copying. So all we did was just copy that, right? And so now after we've done that, this third thing that we're going to do is going to be to actually answer. This is like the answer column to the parentheses. Okay, so whenever I actually go and do this, after I negate this, I'm looking at that third column as far as the truth value that I'm using. And so here, I doubt that would be very colorful. Let's do a green. Okay, right here, we're going to now do what it says to do, which is this. It's saying to do the if this, then that. It's also saying in that hint, the only time I equal F is if I start at T and I go to F. And if I do this, I can find those right here. And I could also find that right here because I'm looking at here. Start at T, go to F. That was what I ended up getting as an outcome. And then this one, I started at T and I went to F. That right there that I underlined just with a like a horizontal line, that was my outcome. Everything else, if you actually look at them, They start at F and they go to T. That equals true. Start at F, go to F. That equals true, because there's my hint. Yeah, that one is the lottery. The one-sided arrow is the lottery. I'm not lying. I'm literally, I would be like, because I'm starting right here, this first case, right there, right? I'd be like, I didn't play and I won. That's cool. Right? I didn't play and I didn't win. Well, I should have played. Okay, I played and I won. Great. I played and I didn't win. Well, I'm upset at that, right? And then I didn't play and I won. That's good. I didn't play and I didn't win. I should have played, but I can't be mad. Right? And then I played and I won. That's what you want. And then that very last one is like, I played and I didn't win. And that was when it's like, hey, I'm not happy. I got that false as that outcome. Okay. Now, this would be where after I do this work, I would have my pencil and I would kind of start covering things up if I needed to, because, and y'all can't see it, but that pink highlight is like covered up right now. And then that yellow highlight's being covered up right now because the answer column to that whole parenthesis is what I have highlighted in green. So moving on to the other parts of this statement, whenever I look back at the parentheses, I know there's 3 different sets of numbers, but it's just that middle one that's actually like the answer for the parentheses, okay? This one right here? No, the green ones, if everything, okay, so it's like T to T is true. And then T to F, that's the only false. This one, what if I did F to F? That's true. What if I did F to T? That's true. So because the only one that gives me false is the one I have circled, it's the one that I specifically found, answered them first, and then the rest all ended up being true, 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 true. It's a lot though. I know it's a lot. So y'all literally ask me all kinds of questions, and I have so many office hours. You can come hanging out with me. Like I literally do this for a living because it's what I love. Okay. Okay. So we finished like that parenthesis, right? We needed to do that first step. We just copied the R. The second step was to negate the Q. The third step was what? Oh, Jennifer Nicole. Oh, thank you. The third step was what is this telling me to do, right? And so I went ahead and I answered that answer column for that arrow, for that connective, for that operation, right? Now the parentheses are done because this little asterisk, this little star on 3 means that's my answer column. I'm not looking at 1 or 2 anymore. I'm only looking at that last one that I did, right? So now it's like, let me look outside of the parentheses. What do I have going on there?
The very first one.
See, and that's because it goes from F to T, but I said that would be the one that messes people up. This is the only one that'll give you F. Even though this has an F and even though it also has a T, it doesn't mean it's a false. This one's actually true. It's that because order matters. If you start at T and you go to F, you get an F. But if you start at F and you go to T, you get a true. Okay, so now let's look outside of the parentheses. And what I would do, because the actual connective of that biconditional, that's going to be the very, very, very last, right? So the next thing I would do is I need to negate that P. I need to do not P. P is 4 T's and 4 F's. I'm going to do 4 F's and 4 T's. I'm just going to flip it. You do the exact opposite truth value that you see in this P column. Because what I'm doing is I'm negating that whole entire column. I'm negating that statement, whatever that statement may be. Okay, so this one right here. Blah, blah, blah. That was the 4th thing we did, right? Just to kind of show you, like I did this first, I did this second. The 3rd thing with the asterisk, that's like your answer column for your parentheses. What did I do next? Okay, I negated that P. Lastly, to answer this whole statement, because basically what it is, it's like a compound statement, is I need to. This one could get tricky, and I hope it doesn't, but it could. So if it does, don't feel bad. Okay, this is my final answer. What you have to understand is I'm using what's to the left of it. It's called the antecedent, right? I'm using what's to the left of it. What follows before this biconditional statement, which is this 4th row. And I'm then also looking at this 3rd row. those are the two rows that I'm using when I do the if and only if. And guess what? If and only if the arrow points in both directions, they both have to be the same truth value to get true. Okay, and this is where I'm looking. So it's hard too, because I can't be like, hey, okay, no, well, watch me cover these up. Okay, I mean, I probably could, but then I couldn't. Oh, let me see. Is there there is. I'm gonna do this for just 1 second and then we'll see if it's too light. I thought I could literally cover it up. Y'all, we're not looking at this one and we're not looking at that one. Okay, we're only looking at 4 and then 3. Whenever I'm doing this like math, technically comparing these truth values, those are the only 2 things I'm looking at. Okay, what I don't have highlighted in black right now.
So you just want to compare the 5
To this, well, it could be, but that's just, sometimes things work out and you're like, oh, but it might not be for, what's it called? Like on purpose. Okay, this is what we're doing right here. If and only if F would give me a what? Would give me a what? If and only if. Hey, if it was a if then, yes, you're right. But this one I'm doing, now I'm doing this statement right here. I'm doing that connective. I'm doing that operation. So if and only if true, those are not both T's or both F's. They don't match. They're not doubles. So I get a false. Just to kind of say that, okay? Now I'm doing F, if and only if T, that's a false. F, if and only if T, that's a false. F, if and only if F, they're both doubles, so you get a true. Okay, true, if and only if true is a true, true is a true, true is a true, false is a. This right here, this fifth thing, this is the actual answer right there. Yep, yeah. And that's back here. I know it's kind of hard, but I kind of did like a little hint for this right there, TT and FF equals T. I did just kind of run out of room. If I try to delete things, it's still start deleting all kinds of stuff. But that was my little baby horrible shorthand to be like, if they both match, you get a true as an outcome. It's a puzzle. All math is a puzzle, to be completely honest with you. Math, period, is just about change, noticing change, seeing change, and putting things together. But yeah, puzzle, so much fun. Y'all, I have like extra credit only for this class, which I stopped giving to people because someone cussed me out. But it's literally what I did was create all these little puzzles using truth tables and the sets, and so much fun. Yep. Okay, so we did spend a little bit of time on that. Let me continue on. In all honesty, Jennifer, you could just define this, and then we'll go to that example, because I could just tell you what it's looking for on the homework. I do wish this class was like a 4-hour block or something. Sorry, I have problems. I have a shirt. This is, of course I have problems. I'm a math professor and it's so old. I need a new one. Y'all should see my office, man. Y'all would understand me so much better. Okay, so let me define some things for y'all. The first thing that I'm going to find, it's either called, because people change it, books change it, everyone always changes things. It's either called a contradiction or a self-contradiction. I've always called it a self-contradiction. It's technically like, just call it a self-contradiction. If you see in your homework contradiction, it is the exact same thing. Okay, a self-contradiction. Now, if it was up to me, I would teach only this. Now I would teach this, Cal 3 and linear algebra, maybe DiffEq. Sorry. I get so excited. Okay, so a self-contradiction. Okay, so what we've been working on with like the statements and then all the different connectives in the parentheses are called compound statements, right? Because it's multiple things being put together, right? So a self-contradiction is a compound statement. So what we've been working on. Let me see if I want to reword that. Is a compound statement is a compound statement that has an answer column that is, it sounds weird, I'll explain it though, but that is always false. The actual definition is a compound statement that is always false. But that sounds weird, right? Because that's saying like, oh, you can't have falses anywhere, and that's not what it's implying. What it's saying is you're gonna have a compound statement like we just did. And whenever you get through all of your different work and you get to your final answer column, if it's all false, it's a self-contradiction.
So you
No.
just have to
Yep.
play the game.
Yeah, Scott, it's a beautiful, beautiful game. Because it is true. I mean, it's like, so. No, there's not a way. Even I can't do it. Like, I actually have to sit there and like solve it. I could get so far into one and be like, okay, it's going to equal it. But when you just look at it, there's so many different things that they could throw at it. And it's never the same. That, I mean, you would be cheating yourself if you just guess, because you have a 50-50 shot. And like, what are you doing? You know what I mean? Like you're losing out on points if you just guess. Okay. So a compound statement that has an answer column that is always false. Okay. So do y'all understand what I'm saying? You do the work, and your very last your very last answer column literally is just all F's. It literally is just always false. Okay, so look right here. Whenever we did this one, do you see the answer column that says 5 answer column? Do you see? Yeah. That whole, this is the compound statement that we did. That whole thing right there with the P's and the Q's and the knots, that's a compound statement. So if I get through all of my work and this answer column goes F, then what we can say about that compound statement is that it's a contradiction. It's a self-contradiction because its answer column is all false. Okay. So we're just going to kind of define that because I do think it's okay to just kind of define it. The homework will actually have, I feel like that's like not broken up at all. The homework will actually have a compound statement that you solve. And if you run into one single T, then it's not a contradiction. Okay. If it's all F's, then it is a contradiction. Only on the answer column, 100%. Anywhere else you can have T's and F's, obviously it's going to happen. But you can like do so much work here and do so much work here that then whenever you put whatever last connective you have, you notice like if it's a biconditional and none of them are doubles, you get F. You can have 7 F's and 1 T. It's not a contradiction.
So
It just happens to be a compound statement that is just not a contradiction. No, you're fine.
will it be presented in like a, you have like a word problem, so maybe you could identify if it says something like all squares are circles.
So on the homework, okay, when I taught at TJC, we did have problems like that. And we actually did, it was more like logic, like real world logic was put behind it so that you could actually say yes or no. And in this book, it's not, it's all truth tables. Exam 2 is all truth tables. And then like after you do a truth table, it'll be like, also define it. Is it a tautology or is it a self-contradiction? Or, is it neither? That comes right now. So if a self-contradiction is something that is a compound statement where the answer column is all false, a tautology is, I mean, through process of elimination, y'all could probably go ahead and say, what do you think it is? Yes. DJ, was that you?
Yep.
All true. I'm gonna actually change this to black. I didn't like how I wrote it in all purple in the last one. Okay, so a tautology is a compound statement that has an answer column that is always true. I know it sounds weird to say that it's always true, but what it's saying is you have a compound statement. Every single one is like a snowflake. They are completely different. You can change one negation, one connective, and it changes everything. And so you have this compound statement and you do all this work and you like, there's falses and there's trues everywhere. And then at the very end, you notice that all you've written in your answer column is all trues. one single F would keep it from being a tautology, just like one single T would keep a self-contradiction from happening. Okay, so hold on. A compound statement is neither if answer column is a combination of truth values. I feel like I already said that. Let me go and write it just for everybody. So my words are written and no one can say I never said it. And you'll see my blue. Okay. A compound statement. This is kind of moot in a way because it's saying the same thing we've already said, but like in a different way. A compound statement is neither if answer column is a combination of truth values. So the example that we did, that long one with the PQR, we ended up getting some T's and some F's. We wouldn't necessarily say it's not a self-contradiction. We wouldn't necessarily say it's not a tautology. We would just say it's neither of them. Just kind of roll them both together. Okay. And so far, I think everything we have worked on is just neither of them. On the homework, it'll say, is this a self-contradiction? You could either just roll the dice and select the bubble that says yes, or select the bubble that says no, you'll get it right or you'll get it wrong. They might change it. So you could just keep getting it wrong and you don't know. Literally just take a piece of paper, solve the truth table. It's the best practice ever for you to do these over and over and over again. And then you'll know answer column is all F. So yes, that is a self-contradiction. Okay. And then if it asks you if something is a tautology, a self-contradiction, or neither, it's wanting, is it all T's or is it all F's or is it a combination of? Okay. So there's also examples on the homework that it's going to word things kind of completely different. You'll see the compound statement, but instead of you having to set up a whole PQR like 8 case table, it is specifically only wanting to know what happens on a certain case. Okay, so let me write it out and then I'll kind of explain to you what's going on here. Okay, so not example. I need to tell you what we're doing first. How to determine this is what we're fixing to learn. We're going to learn how to determine truth value of statement given truth values of the simple statements. If you wanted to be concise, it would be how to determine the truth value of compound statement right here, given the truth values of the simple statements. Okay, sorry about that. And then just for clarification of what it means, we're going to go ahead and say the simple statements P, Q, and R. Okay, so we're going to determine the truth value of a compound statement. So like the whole thing we just worked on, right? But instead of it wanting the whole answer column with all 8 truth values, depending on which case you're looking at, it just wants to know one specific case. Okay. And so I'm going to go up just a little bit because a lot of that should be written. And now we can do an example. 2, 3, 4 of these are on the homework. I don't know. They're supposed to be simpler. And this one, I'm trying to think because I didn't see an example like that on, I actually do think I tested them on that. I wrote something like TVCC is a college in Athens. Beyonce is a doctor in Kaufman. But you know what I mean? Like just random things. And it's like you apply that real knowledge to this is true. This is false. You're a student in my class. This is true. And then like I put connectives in between them. So there is a way to like put real like words on them. We'll see more than likely, maybe that's what 3.4 does. But in 3.3, it is just all truth tables. Okay, so this is how it starts. It says given P is false. Q is true. And R is false. So do you see how it's literally like it's picking out a specific case? It's not having you do a truth table for every single outcome that's possible. It specifically wants to know when P is false, Q is true, and R is false. So what's that? FTF. So that's pretty far down to the bottom. If you look at our setup, FTF, it wants us to figure out what this truth value ended up being, right? You have to do the whole table. We're just going to specifically look at one thing. It was not that compound statement, but it just wants us to look at one specific case. That's what it's wanting us to do. And this is our find the value of. And then kind of a little bit underneath it, I'm going to go ahead and write it. It is going to be open Q, I'm sorry, P. I laughed and then I got distracted.
So you're writing,
And Q, I'm writing the compound statement. And then what we're going to do, we're going to put the truth values that they gave us underneath them, and then just look at the truth values and the connectives the same way my little shortcuts look. So you'll see. If, I'm sorry, open P and Q, close, if and only if open, Q, or not R. Now, we know how to do this with the setup. We have all the different 8 possibilities, all the T's, all the F's. We work on all the individual columns. That's what gets confusing, right? Now, after you do it so long, like, yes, it can be fun. Hopefully it does get fun for y'all. This, instead of it being like, hey, do a whole entire setup, it specifically wants us to look at when P is false, Q is true, and R is false. So let me change my colors here. Okay, so, and if you want to keep the parentheses for a while, I usually do sometimes because I just think that it's good to do. I'm going to replace. What is P? P is what? False. And what did this give us? Q is what? True. Close. My biconditional symbol. Open. What is Q? True. The disjunction symbol. And then right here, you got 2 different things you could do. You could do the tilde and then write what R is, and then do a whole other line of work negating it. Or why don't you just negate it right now? What does it say R is? R is what? So what is the negation of R? Do you see what I mean? You can go ahead and like apply that negation right then. And then close. And then now let's go down a line. Okay, so if you want to, let me go ahead and we'll do red. I never do red. Okay, we're gonna do our little hints. What's my little hint for my conjunction? My hint with my conjunction is true and true equal true, right? Because why? That's a hint for a reason. That is the what? Only time I get true. Therefore, when I look in this first set of parentheses, it almost looks like the word fat, right? F, and then the and then the T. That is using a conjunction. But guess what? That is not that combination of truth values. So my outcome, what I get right here is going to be false. Then I have the biconditional symbol. Obviously, I haven't really applied that yet, right? I'm working in the parentheses. And then whenever I get to this disjunction, I know with the disjunction, that's this or that or both. And what I know about that, my little hint with this symbol was that the only time I get false was whenever they were both false. When I look inside of this second set of parentheses, I don't have F or F. I have something completely different. If my red over there is the only time it's false, that's telling me that this outcome is. And then now I'm just looking at what? F, if and only if T, those don't match. They're not doubles. They're not both the same. This arrow that points in both directions means I need them to be both the same. So my final outcome is you're done. But do you see what I'm saying? You literally just solved what we've been solving in this big, huge thing. This is supposed to be easier, but sometimes it actually is harder for some people. Okay. So the red is my little hints, right? I'm using this little red hint and I'm looking right here. Whenever I see that that's not my hint that I need, that actually tells me, right? That actually tells me what the next line of work is. And then I want to say, because now I am wondering if I tested them on something we didn't go over. I don't think I did. But I do believe in 3.4. I do have a homework example, y'all, that we can do. It's just like a little bitty one. Actually, I have two different examples. But I do want to say that, oh, let me do my hint here. My hint here was TT or FF is what equaled true. You know what, instead of writing or, let me just, right? That's what I was looking for. So I applied this little rule that I have to that and then this to that. Let me show y'all something. I don't have it here because I think maybe I usually wait until the very end to give it to y'all. It's been a year since I've taught this, but this is something that I usually try to write on the board. If not, it's definitely something that could be on your notebook for a test. And it looks something like this. Okay. You said I'm fixing to do? I'm going to combine all of them. All right. So I know we have, when it's just two, because if you really, really think about it, two simple statements is the majority of like how we set things up, how we get our shortcuts, how we figure everything out, right? And so it's going to be the easiest and simplest way for you to remember all these different operations. I'm sorry, why did I do that? There we go. Whenever I was at TJC, because it was the very, very first time I ever taught this, the way the exam would start, and I strayed away from it. I don't really remember why. I think it was just a lot of work, but I strayed away from it. I would give y'all this blank, hand it to you, have you fill it out, right? Like without your note card, without your cheat, without anything, just kind of off memory. Then whenever you actually started your exam, I would actually give this to you and it's filled out. That way you don't like set yourself up for failure and answer anything wrong. But it was a way to kind of see like, was it actually remembered or is it just on your note card? And like, I think it ended up being like 16 points or 15 points. It was crazy. But I personally, I just write it on the board. For this class, this could stay up there. I know I have my simple statements, right? Now, yeah, yes, always. And I have to do a 3 compound statement type of thing. There's gonna be a lot. And I always time myself and I always do it as long as I can do it under 15 minutes. My first student could get it done within 45. And then there's a whole other 30 minutes left for everybody else to finish. Okay. But all of it will be anything that I usually try to like say over and over again. You're given this, you will be given that. It's going to be all of this, like the blanks of the truth table that you have to answer. Well, let's do this. Okay. So this right here, I only have to negate P one time because all it's doing is showing me how to negate, right? And so what I have is true. Is that a different color purple? Yeah, it is. And then what about my and? My and, obviously, I shouldn't have to write here, y'all. P and Q, because what am I doing? I'm doing P and Q. This, I'm just shorthand, okay? And, okay, is this and this true at the same time? Yes. Okay, is T and F true? No. Is F and T true? No. Is F and F true at the same time? No. They might be the same value, but they're not both true, right? Because remember, my little shortcut here was T and T is the only way I get T. Now let's do the disjunction. The disjunction is T or T, true. What I would get here, hold on, let me just make sure I'm using the right colors. Yes. What I would get here is true. At least one of them is true. Then is T or F true? Yes, at least one of them is. Is F or T true? Yes, at least one of them is. Is F or F true? No. So I would get, the only one that's standing out is the one I'm trying to do in purple, right? On the and, the one T is the one that stands out. On the or, it's the one F that stands out. And then I know that my shortcut here is F or F. It's the only time I get F. Okay, so let's talk about this one. With our biconditional, we had, I'm going to answer it first. I'll do the shortcut. If I play the lottery and I win, I'm happy. If, let's go to the very bottom. I don't play the lottery, I don't win. I'm not mad, so I should be happy. Technically, I can't be mad because I didn't play. And then I did not play and I won. I would definitely be happy about that. And then the last one is I played the lottery and I did not win. That actually would upset me. So with the conditional, I'm kind of like, hey, I'm happy is true, and hey, I'm not happy is false. And I know here that when I start with T and then go to F, because order matters, that is the only time I get F. I'll point this out, and I'm not trying to confuse anybody, but with the conditional, this one right here, a lot of people want to make that false also, okay? It's only when you start at T and you go to F that you get a false. Okay, even though these both have the same letters, if you notice, I don't get a false. And remember, this is something that you could use on the test, on your note card. And I usually also try to write it on the board. So this needs to be like y'all's holy grail, pretty much for the end of the semester, but for sure for exam 2. Biconditional. Biconditional. Okay, so with the biconditional, the arrow is pointing in both directions. What I ask myself is if they're both the same value, right? So T, if and only if T, yes, those are both the same. And so it does end up resulting in a true. And then T, if and only if F, those are not the same. Those aren't the same values. So what I actually end up getting for my outcome is a false. If F, then T, those are not both the same. And so what I end up getting is a false. And then lastly, F, if and only if F, I feel like I said something wrong a second ago. F, if and only if F, those are both the same, I get a true. And then the hint's always been, and honestly, it sucks to write that conditional, a biconditional arrow every time. So that's why I've always done like 2 T's equal a T and 2 F's equal an F. Just for this one, because I just get lazy and I'll leave off that double arrow sometimes. Okay, but this is me saying,
Yeah.
oh, yes, sorry. I'm trying to explain why. See, I'm just testing you. I say, you're good, bonus point. I'm just trying to explain why I don't draw that arrow in between them because it's like, I just get lazy. What am I telling myself? They both need a match. They both got to be the same because that's going to be wherever it ended up equaling a T is as an outcome. Sorry, once I mess it up, I start stuttering. I get in my head really bad. I'll like lose sleep. It'll be a whole ordeal. I'm just kidding. Does that kind of make sense? This right here, this is very important to us for exam 2 and for the homework, honestly. Okay, this right here would help you answer 3.2 and 3.3. And then I think that's it, y'all. Let me cancel this because I do need to give you all y'all's exams and I don't want to be saying anything.